At the lead code problem, rotate image. So this problem is categorized as a Microsoft coding interview question. So for this problem, you'll be given a square matrix and you're supposed to rotate it by 90 degrees. And so they're given us an example of how or what they're looking for. So here given this 1, 2, 3, 4, 5, 6, 7, 8, 9. So we move the first row towards the last column. So it becomes like this. And another restriction they have put in place is that we should modify the entire array in place. That means we cannot create a new 2D array and try copying the elements into that array. So yeah, I think this usually the way they ask this problem is they'll ask you to do it, and most people they create a duplicate array and they copy over the rows into the columns, and later then the interviewer will ask them, okay, now if I ask you to do it in place, how would you go about it? So that's how I think they categorize you as SD1 versus SD2. So yeah, given this problem that we have to do it in place, we have to think about how logically we can do it. So yeah, given this 2D array, so we can see like the way they're doing it is that essentially they're moving the first row towards the last column. So the first moves here, 3 moves towards the end here, and 9 moves towards the leftmost, the bottom left row. So essentially we are just keep swapping the elements across the edges, and we keep doing it until all of the elements have been processed. So here's another example of how 5 moves towards the last column, and 11 moves towards the last row, 16 moves towards the first. So given that they've asked us to do it in place, we need to try swapping the numbers, but we need to do it in such a way that so essentially since it's a square, we'll have to do it 4 times. So yeah, let me just try coding it so it'll make more sense. So first thing we need to do is, since it's a square, we'll keep track of what the top, left, bottom, right are, and we'll keep swapping the numbers from those edges, and we'll keep doing it until all of the elements in the array have been processed. So yeah, let's put that. So yeah, now we have the 4 numbers, and we're using it to keep track of what the top, left, bottom, right are. So while we need to keep processing them while these elements are lesser than right, and top is less than bottom. So yeah, the way we'll do it is we're going to try swapping the numbers. So for that, let's first keep a temporary variable to store the top left. So we just say matrix. So here top is the row number and left is the column number. So we need to replace this top left with the value. So here, given this example, we need to replace it with the value from the bottom left. So we just say matrix top left. So you can understand, right? Essentially what we are doing is, given this number, we are going to replace 1 with 7, and 1 we have put it in a temporary variable, we'll swap it towards the end. Then we say matrix bottom left. So we need to replace 7 with 9, and this one is the bottom right. So we just say and now bottom right, we set the value to the top right. And finally top right, we just replace the value of the temporary variable which we have stored earlier. So hopefully this makes sense. Essentially what we have done is we are now trying to swap the numbers in all of the edges. So this one solves it only for the 4 edges. Now we need to keep moving it across. So for example, here we need to move it across the first row. So for that we need to create another for loop. So So the number of times we'll be having it to process will be the right minus left, because that's the number of values that are missing. So now we need to think logically of how we are going to process. So the first time we are going to replace all the values in the first row. So the row will remain the same, but the value of the column will keep incrementing by I. So we just say matrix left plus I. Same thing here. Here the column will remain the same. It'll always be the leftmost column, but the bottom will keep decrementing. So we'll say bottom minus I. And here for this one, it'll always be the last row, but the column will also keep decrementing. So we say right minus I. And here, the column will be the last column, but the row will keep incrementing. So we say top plus I. So in that way, now we are processing it. So we'll keep doing it all over the edges. So first we'll process the entire outer edge of the square, and then we keep going down until we process all the elements. So after that, we just say top plus plus. So yeah, hopefully, let me do a recap again. So essentially what we did was we took 4 variables, and they used to keep, you can see a spelling here. They used to keep track of the 4 edges of the square. And the way we're going to do is we're going to process the outermost square, and we keep decrementing it, and we keep doing it until all of the elements have been processed. And essentially we're going to try swapping the numbers of the edges. So first time we take the top, the top edge, and then we keep replacing it with the bottom left one, and we do it with all the 4 edges. And after that's done, we keep using this variable to keep incrementing it. And the count we say right minus left, because here given example, row is 0, column is 2. We just need to process these 2 elements, 1 and 2. So we need to do it twice. So that value will be the difference of the start and the end basically. So that's what we are doing, and we keep doing it until all of the elements have been processed. So yeah, hopefully that made sense. Let's try running it. Oh, maybe I missed it. Okay, it seems that we had a bad. I guess I didn't align it properly. Yeah, let's try again. So yeah, all the use cases are passed. Let's try submitting it. So yeah, details of the solution. So the time complexity will be O of n, where n is the number of elements inside of the array. So we have to basically keep processing all of them. And for space complexity, everything is being done in place. So it's going to be O of 1. So yeah, let me know if that solution made sense, and yeah, leave comments if there's an easier solution for it.